So we're going to do this section for 3 days. Today's day 1. We're going to get lots and lots of practice with what we're starting today. Don't panic. We're not just going to do a little 20-minute lesson and then I'm going to leave you on your own. We're just going to practice, practice, practice all week to get used to this stuff, okay? All right, so a couple of your fundamental identities. Fundamental identities are on the top left corner of your paper. They're the ones that are numbered 1, 2, 3, and 4. Those are the only 4 groups we're going to use in this section, okay? So top left corner, those 4 groups are the only things you have to worry about this week. Reciprocal identities should be familiar to you. We used those a lot in the last chapter. Sine and cosecant are reciprocals, flip them. Cosine and secant are reciprocals, flip them, so on and so forth. Quotient identities, we've used those before a lot in our unit circle, especially like tangent was y over x, or sine over cosine. Cotangent is x over y, or cosine over sine. We also briefly in the last chapter did the Pythagorean identities. Remember writing these down? Okay, what I want you to do on your sheet, like in the margin next to the Pythagorean identities, there are equivalent alternative versions of these. Now, where these come from, it's just taking one of the terms and moving it to the other side. For example, if in this first one I subtract sine squared on both sides, I end up with the one on the bottom here. Cosine squared is equal to 1 minus sine squared. So it's the same formula, things are just moved around a little bit. So take a minute and write these down. I'll move it up a little bit for you. In the margin next to the ones that you have. So there should be 2 next to sine squared plus cosine squared, 2 next to 1 plus cotangent squared, and then 2 next to 1 plus tangent squared. Often when we see these, you might see the equivalent form. So it's nice to be able to find them on your paper quickly if you're looking for them. Got it? All right. First few problems we're going to do with these. We did something like this in the last chapter where you're given one trig value and you need to use identities to find other trig values. We're going to use identities to do this as keywords here. And the instructions would be for your homework. It's going to say use identities. So if I were checking in on the homework quiz, that's the work I would want to see. But another way to do these problems is with the triangles. You can draw a triangle in quadrant, whatever, you can label your sides, and then you can find any ratio you want. So the triangle method, although useful, is only at this point a check for us. We need to make sure we're using identities to do these problems. All right, so first problem. In this one we are given cosine of theta is negative 5/13. And then we're also told our angle theta is between pi and 3 pi over 2. If we are between pi and 3 pi over 2, where is that on our, think about your unit circle? It's in quadrant 3, for sure. So if, again, we were doing this with a triangle, we could draw a triangle in quadrant 3 and use that as a check. For our purposes now, what that's going to be helpful for is it's going to help us figure out what's supposed to be positive and what's supposed to be negative. So remember, all students take calculus. If I'm in quadrant 3, what should be positive in my answers? Only tangent and cotangent, meaning if I find anything else, it should be negative. And that's going to come up a lot. You're going to get pluses and minuses because you're solving things with square roots often. So you want to know what quadrant you're in to determine if it is a plus or a minus. Okay, so using identities, I have cosine. In this problem, we are looking for tangent. So I have to figure out a way, looking at those, again, just fundamental identities, how I can get from cosine to tangent. Now, the only function, or the only identity that relates them together in the same is a quotient identity, but you don't have sine, so that one's not helpful. So that means it's going to take you more than one step. I need to go from cosine to another function, and then from that function to tangent. So you kind of have to figure out your path to get there. So again, reciprocal, Pythagorean, quotient, what do we think?
Pythagorean, sine squared x plus cosine squared.
Okay. Okay, so let's find sine using this guy. And then if I know sine and cosine, what am I going to be able to do in the next step?
Wait, I just have a question.
Okay.
Since you're trying to find sine, should you do the sine squared x equals 1 minus cosine x?
Yeah, so that's what this is, and eventually we're going to subtract anyway. So you could always start with that alternative version if you want to. This is probably, when you memorize, though, the one that you're going to know off the top of your head if you don't have the paper in front of you. Okay, so let's fill in our cosine. Our cosine is negative 5/13. Okay, what's negative 5/13 squared? 25 over, okay, and then we're going to subtract that number to the other side. So think of this with a common denominator. Think of one like 169 over 169 minus 25 over 169. What will that be? 169 take away 25. 144 over 169. That's for English letters. It's fine. You're good. How do I solve for sine? Square root. Sine theta equals square root of 144 is 12. Square root of 169 is 13. And now technically it's a plus or minus, but remember we're in quadrant 3. So will sine be positive or negative if we're in quadrant 3? It will be negative. Okay? All right, so now I know sine and cosine. Remember the goal here was to get tangent. How do I get tangent? Sine over cosine. Sine is negative 12/13. Cosine was negative 5/13. How does that simplify? Positive 12 over 5 because the 13s cancel, my negatives cancel, and then again we're in quadrant 3, tangent's positive. That's a good little check at the end. This is the same answer you would get if you drew that triangle in quadrant 3, labeled your sides, and eventually did opposite over adjacent. On the test, you will have to use identities quite often in calculus. So for right now, yes, there's an easier way to do this specific type of problem, but it will not necessarily be always calculations. When we get to our proofs, when we start substituting here, intervals and all those wonderful things you do. So think of what we're doing right now as a way to get comfortable with your identities. Okay. Yes.
Is there always like one specific equation, or could you have done like the Pythagorean identities and then like those like a secant and just flip them? So is there like multiple ways?
Oh yeah, for sure. Actually, that's how first period did it. First period took cosine, flipped it, and made it a secant, and then they used the 1 plus tangent squared identity equals secant squared.
Okay.
So that would have been fine too. Okay. So we all know there's not one right way to do these. You're just kind of deciding your path, your road to get from one to the other.
That's like part of the proof.
So you'll see what the proofs look like eventually. Proofs eventually will not have any numbers in them. Okay. All right. I want you guys to try this one. Let me do a screen share. We don't need that bottom part there. All right. So I want you guys to try this one. You are given cotangent is 3/4. You are given that x, the angle here, is between pi and 3 pi over 2, and you need to use identities to find all of the other functions. Okay, so now it's not asking for just one, it's asking for all of them. If you want to check your answer, you can draw a triangle. All right, so maybe you want to find a friend to do this with? You can do it. All right. All right, use identities. Let's get some practice with them. Find all the remaining trig functions. what order did you get them in? Maybe let's kind of talk through that. If you have cotangent, what else do you pretty much have? I would probably have found that one first.
I got secant.
And then you could get secant using which identity?
The 1 plus 1
The Pythagorean identity, squared. And then if you know secant, you can get cosine. And then, what did you get next? Sine using a Pythagorean identity, probably. And then cosecant, last but not
I
least.
really have no clue what I'm saying. Okay. I know the first one I forgot cotangent until like you mentioned it.
And if you got your pluses and minuses wrong, that's always something you can go back and look at the end. You're in quadrant 3, so at the very end, everything else should be negative except for tangent and cotangent.
Oh shoot, you're
Okay?
Yeah, how did you
Good?
Yeah.
Questions? So when we see these problems on the homework, make sure you are using identities, not a triangle unless you're checking it. All right. The fourth and final group of fundamental identities on your sheet is called the even odd identities, and they are these. So do you remember in the last chapter, when we labeled the properties of all of our graphs, we labeled whether the sines and cosines and tangents were even or odd? That was one of the things that's in your notes. And when we did that, we found that sine, cosecant, tangent, and cotangent were all odd functions because they were symmetric to the origin. And the other two, cosine and secant, were even functions, which is why you see a difference in those two middle ones up here versus the ones on the outer edges here. What you're seeing are the actual algebraic proofs of even and odd. We did these way back in chapter 2. We said that if a function was even, you should be able to plug negative x, or the opposite of x, into the function, and it simplifies back to the original function. So that meant it was even. Or if it was an odd function, we plugged the opposite of x in, and it simplified to the opposite of the original function. Remember doing those?
Yeah.
You plugged in the negative x to determine if it was even, odd, or neither. Okay, so that's what you're seeing here. So pretty much what these are useful for our purposes now are give a negative angle, because that's what x is. It's a negative angle. If you see a negative angle in an odd function, the 4 on the outside, you can just bring it out front. If you see a negative angle on the inside of the 2 here, the even, you could just pretty much drop it and get rid of it. Okay, so even odd for our purposes is a way to simplify a negative angle. We can either bring it out front if it's odd or drop it if it's even.
So you're saying if it's like secant of negative 50, you could just make it secant of 50?
Exactly. And if it was sine, let's say it was sine of negative 30, I could simplify it to negative sine 30. So we don't have to deal with negative angles anymore. Okay. All right. Last couple of problems we're going to do today are some simplifying problems. This is a mix of, I put the wrong button. This is a mix of algebra and trig identities. Okay. You are simplifying either algebraically with things we know how to do, like distributing, FOILing, combining like terms, multiplying by something over itself. All of those things are things that we can do that do not change an expression, what it's equal to, just changes the way it looks. And then also our identities. If we see an identity, we can maybe replace something in our equation with something ideally simpler. Let me give you an example. In this first one, what do these two terms have in common? Signs. One way to simplify an expression is to factor. And if they have something in common, I can factor out a common factor. So if I take a sine x out of both of those terms, so we're undistributing it here, what will I be left with? Sine squared plus cosine squared. Does that look familiar? Okay, so these are reasons we want to memorize our identities, because if we see something like this, it should jog something in our brain that says, hey, that's a thing, find it on my paper. Sine squared plus cosine squared is equal to 1. And sine times 1 is sine. When you get down to a single function, you're done. That's as far as you're going to be able to simplify it. So cool.
Would you always be able to simplify down to it?
Yes, or it might be like sine plus 1. Nothing else you can do with it. 1 or 2 terms is, I think, how the book sets these up. Okay, I'm going to rewrite this one because I don't like how it's typed. So it's secant x plus 1, secant x minus 1, all over sine squared. Okay, so for right now, no identities here. So we're just going to try to simplify with some algebra. What's something algebraically you would be able to do with this? Multiply the numerators. And if we have 2 terms times 2 terms, what are we doing to multiply? Foil. Okay, so we're going to FOIL the numerator. What is secant times secant? Secant squared. Outside term, secant times negative 1. Inside term, secant times 1. Positive secant. And then my last term's positive 1 times negative 1. Negative 1. What happens? Middles cancel. So now I have secant squared minus 1 over sine squared. As soon as I see something that's squared with a 1 next to it, my eyes are going to those Pythagorean identities. Is secant squared minus 1 a thing? It is, yeah, it's one of the alternative versions, right? Secant squared minus 1 is equal to tangent squared. So now I have tangent over sine. Okay.
Where do we go from here? That's the question.
Oh, it's not quite anything yet. If I had cosine over sine, it would be a thing.
That would be cooking.
Okay, can I rewrite tangent another way? What else besides cotangent would be an option?
Tangent
Maybe
equals
sine over
sine over
I just
cosine.
sit down.
Oh, that's just gonna be cool.
Hi. It's great. Everything's wonderful. Bye.
I got it.
Okay. I got the wrong number.
Man, dog.
All right. So here's why I'm going to use the quotient identity. I'm trying to relate tangent to sine. The quotient identity relates tangent to sine. Now it's tangent squared. So tangent is sine over cosine. Tangent squared would be sine squared over cosine squared. My denominator is not changing. How can I do that division? You've got fraction divided by a fraction. You can instead multiply by its reciprocal. So this is sine squared over cosine squared times the reciprocal of the bottom. What happens? And what am I left with? And 1 over cosine is secant. So 1 over cosine squared is secant squared. Some will be longer than others. Okay? All we're going to do this week is practice this kind of stuff. The more we do it, the easier it's going to get. I promise. All right. Let's try. Let's do the one on the right first. Okay, so I've got secant squared u minus tangent squared of u over cosine squared v plus sine squared v.
I've never done something like this.
Boy, you must
The
be
bottom is 1. Everybody agree with that? Okay, and they're the same angle, v and v, so we can use an identity with them. 1. What about the numerator? Cosine squared plus sine
Oh, we're
squared.
doing that side.
Yeah, oh yeah, we're doing the one on the right first. Top is also 1. Sine secant squared minus tangent squared on your paper. It's 1.
Come on, guys. Correct.
See? More easy. Okay, let's do the one on the left. The one on the left's going to be a couple more steps, yeah. Okay, so right now I have tangent and cotangent. Can I make one look like the other? Because it would be a whole lot easier if everything was the same function at least, right? You have more opportunities to combine and reduce and all that wonderful stuff.
Well, I figured it
I
out.
would still have two different functions then.
You can make it secant squared x over.
There's no squares here, so I wouldn't even
Oh,
look
it's
at
not
those
squared.
Pythagorean
Okay.
identities.
All
All right, let's change tangent to cotangent. Everybody agree? That is one of our reciprocal identities? Okay, so now I have at least all one function here. Again, more opportunities to combine and reduce and things like that if you can do that. All right, so when I look at problems like this, I decide what's gross, and I want to get rid of that. What's the grossest? The top is gross because that cotangent. So wouldn't it be great if we could get rid of that denominator in the numerator, right? Okay. If I multiplied this by cotangent, would that get rid of that denominator?
Yes.
Okay. I'm not allowed to just multiply any one term by something because that changes it. But I can multiply whatever I want by something over itself, right? If I multiply by cotangent over cotangent, that's equal to 1. So it's going to make it look different, but it's not going to change what it's equal to. Because I want to get rid of that cotangent, I'm going to multiply this whole fraction by cotangent on the top and cotangent on the bottom. And again, it has to be something over itself because it has to be multiplied by 1, and I'm choosing cotangent because that's the gross denominator I'm trying to get rid of. Okay, at this point I can multiply by sine over sine if I want to, it's just not going to get me anywhere. All right, distributed in. Cotangent times 1 gives me cotangent. Cotangent times 1 over cotangent. 1. That's what we wanted, right? We wanted to get rid of that denominator. Cotangent times 1, cotangent. Cotangent times cotangent. Cotangent squared. Okay. I don't have any gross denominators. Nothing cancels yet, right? To cancel in a fraction, you have to have a common factor. And right now there's addition and subtraction. But could I factor to get a common factor? Does anything here factor? Take out a cotangent on the bottom. What would that leave me with if I divided both of those terms by cotangent? 1. Now do I have a common factor? Yes. If I put the numerator in parentheses, it looks even better, right? So I have 1 plus cotangent as a factor in the numerator and in the denominator. What does that leave me with? Okay, good. All right, last problem you're going to need your calculators for. Tomorrow, we're going to be proving, and everything is verifiable. If you are getting a problem that says prove that something is not an identity or not verifiable, that's what we're going to do in this example. Prove that this is not an identity, not a thing. Okay? There are 2 ways to prove that something is not an identity. The first is by showing a counter example. Algebraically, to show that this is not an identity, is you plug a number in, any number you want. Okay, and it's an angle, so pick a nice pretty angle like off of your unit circle would be a good one to choose because you can evaluate those without a calculator. And if you show that both sides are not the same, if one simplifies to a half and the other side simplifies to 1, it's not true, it's not an identity. Okay? So I want to figure out, give me an angle for x, something on a unit circle, like in quadrant 1, 60. And degrees are fine. So let's say I want to show a counterexample for 60. What is the cosine of 60 on your unit circle? X coordinate, 60 degrees. 1/2. What is the sine of 60? Rad 3 over 2. Are those equal? Is 1 minus rad 3 over 2 going to give me a half? No. And worst case, you could always type in your calculator and get a decimal for both sides, right? This one's 0.5, and this one is not 0.5. Okay, so that's a proof that it's not an identity. Okay, algebraically, just plug in a number. And for some reason, if you pick a number that happens to be equal, like sometimes zeros and 90s, things like that with the 1s and 0s, you can get kind of like a false positive. Just pick a different number. Okay? The other way to do it is graphically. If you want to show graphically that something is not an identity, we're going to literally graph it and show that it's not the same graph. So on your graphing calculator, you can have mine loaded up here. We are going to use y1 and y2. In y1, you're going to put the first side, so cosine x. And in y2, you're going to put the second side, 1 minus sine x. Okay, and you want to be in radian mode to do this. Remember, whenever we graph our sines and cosines and tangents, you want to be in radians, degrees, doesn't look so great. Mode. Make sure you're in gradient mode. Okay? And then you can just do this in your standard window, just zoom 6. And remember, I'm trying to show that this is not an identity, so what am I looking for? 2 different lines. Do I have 2 different lines?
Yeah.
That's a graphic proof that these are not equal. This is not an identity. Okay?
Pull our window from my calculator. How do we say that?
You would sketch it off of your screen onto the little axis that I have drawn for you. Isn't that so nice? I can do that. Yes. You're in radian mode. And then I hit zoom 6.
I'll review it.
Okay.
Just for the
Think
one
so?
question.
I'm not. I think you can use a graphic calculator for the whole thing. It's not going to be that helpful. You guys can do all the way up through number 28 on the homework if you want. Okay. All right. To be continued tomorrow. Questions? Homework is due on the day of that homework, which is the day before spring break. So, but if I were you, I would do a little bit each time.
I will be on my play.
Okay, cell phone lotto winner is 8.
Hey! That's mine, yeah.
Double.
Okay.
I love that.